Unit 4, Example 2, going beyond CPC-TC. So given that PA is perpendicular to AR, PB is perpendicular to BR, and AR is congruent to BR, we are asked to prove that PR bisects angle APB. So before we begin, let's think about if that angle is being bisected, is being cut into two congruent parts. So I'm going to call this 3 and 4. So that would show that angle 3 is congruent to angle 4. So I need to show that this relationship exists, and I'm going to do that through CPC-TC, which means I need to prove the two triangles congruent using one of our methods. So I'm going to list our methods out as we've been doing in each example. Again, this video will go over the flow-proof version. And one reason I like the flow-proof is that we can begin with the end in mind. So I know that I'm going to show that PR bisects angle APB. That is what I'm going to conclude with. That is where I am going. And my reason will be that PR cuts angle APB into two congruent parts, which is the definition of an angle bisector. Okay, well I said in order to prove that that is true, I need to show that angle 3 is congruent to angle 4, and the way I'm going to do that is using CPC-TC. And in order to use CPC-TC, I have to first prove two triangles are congruent. So triangle PAR will be shown congruent to triangle PBR, and we haven't yet picked a method. And then we'll fill in the rest of the top of our picture. Okay, so they give me, in the given, PA perpendicular to AR, PB perpendicular to RB, or BR, and that AR and RB are congruent. And again, what's highlighted in yellow, that's not given information, that's what we're proving. So we can't use that to eliminate our choices. So they only gave us one side congruent to the other. I know nothing about PA and nothing about PB, so side, side, side is out. Also, they only gave me one angle in each triangle, so angle, angle, side, and angle, side, angle is out. Okay, if I'm going to have angle, side, angle, then I need to know about PA and PB because that angle needs to be included between the sides, so that is out. I do have right triangles, which means hypotenuse leg is possible. They gave me a leg here, so AR congruent to BR. That is given. And so I can put my method down here that I have. So what does that give me? That gives me a leg. Okay. So I notice that PR is the same as itself, and that will be a hypotenuse. PR congruent to PR. Reflexive property. And that gives me my hypotenuse. Now recall that only right triangles have hypotenuses. I have not stated that these triangles are right triangles, so that's what's going to come next. PA perpendicular to AR, PB perpendicular to BR. That gives, and that's given. Angle A and angle B are right angles. Should have put these in a different spot here because I'm running out of space. Definition of perpendicular lines, or perpendicular lines form right angles. I'm going to have to go up and then go back to this. And then we know that triangle PAR and triangle PBR are right triangles. How do we know that? Definition of a right triangle, or a right triangle has one right angle. A right triangle has one right angle. Perfect. So I've shown that the triangles are right triangles. I have a leg congruent. I have a hypotenuse congruent. PAR, the two triangles are congruent by hypotenuse leg. I can now talk about angle 3 and angle 4 because they are parts of corresponding triangles which are congruent, given that we've proven the two triangles are congruent. And I can say that PR bisects the angle because PR divides the angle into two congruent parts. And that is it.